Good afternoon, Villa 2. This is Mrs. Hughes, and today I'm going to be doing your first flipped math lesson with you. And we're going to be starting this with our next activity, which is activity 2. So I'd like you to make sure you have your notebook in front of you, and we're going to be taking some notes right now. And the first thing we're going to start with is our lesson title. So at the top of your paper, I want you to identify this as Lesson 2-1. And the focus for our lesson today is going to be prime factorization. So we're going to title that right underneath this. Prime factorization. And today, as you take your notes, if you ever need to pause to catch up, go ahead and do that. But I'm going to run us through a few things. I'm going to start off with vocabulary today that we're going to need to understand for the lesson tomorrow that you'll be coming in to practice with. And there's 3 terms that I want you to know. So we're going to label this vocabulary. And the first word that you need to know is factor. And a factor is one of the numbers you multiply to get a product. So an example of this would be if I gave you the equation 4 times 2 equals 8. We have 2 factors here. 4 is one of our factors, and 2 is our other factor. And we multiplied both of those to get our product, which was 8. Our second term that I want you to know is prime number. And what a prime number is. And what a prime number is, it's a natural number greater than 1. That's an N. Then 1 that has exactly 2 factors. Itself and 1. No other factors will go into it. So an example of a prime number would be 2. 2 is a prime number because the only 2 numbers that go into it are 2 times 1, leaving 2 as our prime number. Another example of a prime number would be 5. If we take 5, the only 2 factors we have to get 5 are 5 times 1, leaving 5 as our prime number. So any number you come to that can only be multiplied by 1 to get itself is a prime number. So 6 would not be a prime number because I can multiply 2 times 3 to get 6. So leading from prime numbers, I want to go into composite. And a composite number is going to be everything else that a prime number isn't. And composite numbers is going to be a natural number that has more than 2 factors. So a way I can write this would be like 15. 15 is a composite number because I can take 1 times 3 times 5 to get 15. And right now I have more than 2 factors here. I have 3. Another example of a composite number would be 20. 20, I can say 1 times 4 times 5. I have more than 2 factors here to get 20. Therefore, it's a composite number. Okay, make sure you have all the vocabulary done, and we are going to get started with the lesson. Okay, so now that we have all of the vocabulary down, we're going to start with understanding how do we do prime factorization. And I have a couple of examples for you today. And my first example is going to be example A. And for example A, we are going to find the prime factors of 12. And this is going to be our goal. Now, in your book, you will see this example A. I'm just going to walk you through it right now. And this is called a factor tree. So one of the ways that we can find prime factorization is to use a factor tree. And what a factor tree looks like is if I want to find the prime factor of 12, I place 12 at the very top. And from 12, I think of two factors that I can multiply to have 12 as my product. And I need to create branches for these two numbers. So I think to myself, 3 times 4 would give me 12. So now I look at my next two numbers and I see 3 is a prime number. I can't take this down any further. So I look to 4. 4 is a composite number, so I can create a branch off of the number 4. And here I know that 2 times 2 will give me 4. So when I look at these factors, I see that they are prime, and I can no longer go down on my tree. I have found the prime factors for 12. You want to make sure that you continue factoring until all numbers are prime. And I've done that right up here. Now, once you have your prime numbers, you want to place this into an equation. And we are going to say that 12 equals, and we're going to pull out our prime numbers, and we are going to pull them out from least to greatest in sequential order. So I have my 2, so I circle it and I write it, so I know I've used it, times 2 times my final factor, 3. So now I have my prime factors of 12. Don't forget when you do this, you need to write the prime factors in sequential order. Okay, now just because I found my factor tree this way, I can also find it another way. When I have the number 12 and I'm creating my tree, I can use any factors that I can multiply to get to 12. So I could have used 2 times 6. Again, I have 2 as my prime, so I can't bring that any further. But 6, I can give another branch and find some more factors for 6. And I can say 2 times 3 equals 6. And if I look at this, I'm going to see that my 2 over here matches my 2 over here. My 2 right here matches this one. And then my 3's also match. So your factor tree can have different branches, but you will always come out with the same prime numbers at the very end. Now, if you don't have this all down, go ahead and pause it and get this completed. I am going to move on. Now, in math, there's typically always more than one way to do something. So I want to give you another example of how you can do prime factorization. And this I'm going to call example B. And this is another method. And we're going to use this method to find the factors of 60. Now, the name of this method is called long division notation, and it's going to end up looking like a birthday cake. So what we're going to do is we're going to start off with our number 60, and we're going to start to find the factors. So I'm going to come down here, and I'm going to put 60 out at the very end, and I'm going to create a division symbol. That's going to look like that. And I'm going to ask myself, what is a prime number that can divide into 60? And I come up with the number 2. 2 is a prime number that can go into 60. Now 2 goes into 60 30 times. So I put my quotient on top of my division problem here. And I'm going to continue. I'm going to build on it. So I'm going to ask myself, I'm going to make another division symbol, and I'm just going to cut it a little short to make it a step, and ask myself, what number would divide into 30? Well, 3 can divide into 30, and 3 is a prime number. 3 goes into 30 10 times. I put that up at my quotient. And now I can continue on. 10 is not a prime number, it is composite, so I can divide it again. So I come out here, I leave a little step, and I ask myself, what number goes into 10? Well, 5, which is a prime number, can go into 10. 5 goes into 10 twice. And now I have 2 at the top of my cake. 2 is a prime number, so I am now finished finding the prime factors of 60. And when I go to write this, I want to make sure to write the prime factors in sequential order. So I'm going to begin. I'm going to start with my 2. I'm going to write that over here. I see I have another 2 down here, so I'm going to say 2 times 2. Next would be 3. So 2 times 2 times 3. And then the last one is 5. 2 times 2 times 3 times 5 equals 60. And that's how you would find the prime factorizations using the long division notation. Well, that is our first flipped lesson of the year. Please make sure that you have all of your notes down and be prepared to come in tomorrow and explore prime factorization in a little bit more depth. I look forward to seeing you all tomorrow. Have a great night.